So the last time we saw fundamental units, derived units, and the SI units, and the basic introduction to units and everything. So today we're going to study something else, a new dimension altogether called a dimension. So what is a dimension? The dimensions of a physical quantity are the powers to which a fundamental quantity powers to which a fundamental quantity must be raised to in order to obtain the unit of the quantity. So the fundamental to be raised in order to obtain the unit of the given quantity. Okay. Alright. So for determining the dimensions of physical quantities, they are represented by capital L for length, capital M for mass, and T for time, all enclosed within square brackets. Okay, and we also have I for current and C for luminous intensity. So basically, let us say there's this dimensional equation for speed. So speed is equal to distance upon time. We know it is. So basically, distance is length and time is t. So what does it equate to? L t raised to the power minus 1. And since there are three symbols, we use L, M, T, and we have I and C, which are not used very commonly, but we generally use the three of these. And they are generally written like this. So similar format will be employed here, and we will write it this way: L 1, T minus 1, and M, there's no M, M0 is the dimensional formula. So this is the dimensional equation, and the powers which they are raised to, 1, 0, and minus 1, are called the dimensions. Of speed. Alright. So, or let us say the equation for charge, or let's say, okay, charge. So charge is equal to current into time. Q is equal to IT. So it is basically I and T1. So I1, T1. Representing this, we have I1, T1, M0, L0. So this is the dimensional equation, and 1, 1, 0, 0 are the dimensions. Alright. So we have certain derived quantities and their dimensions. For example, area, the power to which it has to be raised in order to arrive to its unit. So let's say area is length square. So it is L raised to the power 2. So its dimensions are L square, M0, T0, and the symbol or the unit is M square. See? Or let's say acceleration, for that matter, we have acceleration is equal to velocity upon time. So velocity is distance upon time, the whole thing divided by time. So moving on to the next page, so let us say this is it, and then we have length upon time divided by time. So this is length upon time divided by time into 1 upon t, which is equal to L upon t square, which is equal to m0 L1 t raised to the power minus 2, because this is LT minus 2, and its units are meter per second square, or meter raised to the power minus 2, which is also written as this. So you see that there is a relation between the units and the dimensions of a quantity. Similar with force, impulse, work, anything. So now I think you are very much fit to do this. Now let us say, why do we need dimensions? I mean, what is the point of this all? Why do we need to learn something like this? What sense does this make? So there are a couple of uses of this. So to find the correctness, the first use is to find the correctness of a physical equation the correctness of a physical equation. So let us say we have this thing which is written as this. This is a kinematic equation. So now let us write its dimensions, dimensions of the LHS and those of the RHS. So on the LHS we have, let's erase this. Okay, on the LHS we have S, which is L1 T0 M0. On the RHS we have UT, which is L1 M0 T0, and AD square. Half has no units. AD squared will be, so what are the acceleration is L1 M0 T minus 2, and T square is going to be T square. So looking at this, we have L1 M0 T minus 2 minus 2, yeah, it's minus 2 plus 2, A and AM equals AM plus N. This is the formula anyway. So similarly we use it for time, and then we have the equation turning into something like this. So all the things have similar dimensions. So LHS is equal to L1 M0 T0, and the RHS has same dimensions as well. So okay, wait, yes, this is the thing. So to see the correctness of a physical equation, it makes no sense if its dimensions change. For one. Secondly, to find conversion factor between the units of same physical quantity into different system of units. So let us say I want to find how much, or I want to find the conversion factor between dyne and Newton. So dyne is basically the measure of force in CGS, and okay, let's Newton. So this is MKS and this is CGS. Alright, so how is that done? Okay, so we have, let us say, let's do it in the next video. Thanks for watching.